So, after knowing partial differentiation, I know you are pretty pro already. So I would recommend you would also go and watch out partial differentiation chain rule. Alright, if you want to just quickly know what are the things in there, I highly recommend you watch this video. She's a very beautiful girl and a very sweet voice.
Today we're going to be talking about how to use chain rule to find the partial derivatives of...
Anyway, so if you want to know what are the basic stuffs of chain rule and somewhat the in between, the very chim one, and anyway, if you find that you want to know the reason behind certain stuffs, I suggest you watch this. Otherwise, if you want to look at something that is pretty in depth, alright, not too in depth, but rather than the intuition behind all stuffs, I recommend you watch this video. Alright, and then you just click to the part 2 and watch. Alright, but in any of the case, all I'm gonna do now is something different from what you're gonna do. So if you want to watch, you can just watch these things. Otherwise, you can just keep to this and then you check it out. Alright, so this, as I said earlier, this video series comprises only on tackling exam questions and questions that are pretty much weird and tough. So I'm just gonna do out I'm gonna do 2 questions. So the first question I think will be pretty fast, and therefore let's go. So normally they will not ask you to actually find chain rule explicitly. They will not talk about this is chain rule, you go and solve. But they will just give you this question like find partial z partial t of this function z squared is equals to x squared plus y squared, which is the Pythagoras theorem, where x is equals to this, y is equals to this. So from this, as you can see, and I mean this one if you can't see, and this one, what we can suggest is that x and y is changing in terms of time, right? So z is changing in terms of x and y, yet x and y is changing in terms of time. So I would suggest that from here you can straight away know that you need 2 variables, and therefore you will require 2 types of partial differentiation. So what I'm going to do is that we know that partial z partial t can be comprised of partial z partial x, because I'm going to differentiate partial z in terms of x and then multiply by partial x partial t. We can write in terms of this manner. So partial x partial t, if you differentiate this dude over here, you can have, so if you differentiate you have this one, right? If you differentiate this thing in terms of x, you'll get this one. So that's why I say that I will assume that you already is professional in partial differentiation, so these terms are not very unfamiliar with you. Otherwise, good luck. If you don't know anything yet, if you still find that what I'm talking now is a bit alien, then you just go and watch this video.
multivariable functions. And in this particular video,
Her voice is very sweet. Anyway, so this is partial z partial t, alright, because you can cancel each other, it becomes partial z and partial t, right? But you can rewrite in terms of this manner. Later on you'll know why I'm doing this. And then plus, alright, plus partial z partial y and partial y partial t. So same thing, you're gonna differentiate in terms of z in terms of y, alright, partial I think you get what I mean. And then also the partial, when talking about partialing with y, so partial y partial t is the differentiation of t in terms of y, you get what I mean? I think you get what I mean. If you don't get what I mean, then
we're going to be doing 2 problems.
Anyway, so now what I'm gonna do is, firstly, normally in any this type of questions, the first thing I will straight away do is to write down what are the terms: partial z partial x, and then partial x partial t. So I just write down what I need in my stuffs, alright? So I'm just putting it over here, putting it over here, putting it over here, and putting it over here. Alright, so it's pretty fine. And therefore, partial z partial x is just simply differentiating z in terms of x. So let's rewrite this dude over here such that it is easier for us to differentiate. Maybe I should change to green color so that this is better. So instead of writing square root, because if I bring this square over to the other side, I put it in terms of half, so it will be easier. Okay, so if I were to differentiate in terms of x in this case, then I will just bring down the half. If you remember the inner chain rule differentiation, alright, if you don't know anything, never mind, because the name itself is anyway. So I just bring down the half, so x squared plus y squared minus half, and then I differentiate the inner function, which is 2x. So and therefore I would have half times 2x, I will have x, and then x squared plus y squared minus half. And therefore I can just fill it in over here as okay. So now let's clear this a little bit. Now we gotta differentiate in terms of y. Alright, so partial z partial y, right, is same thing. I gotta bring down the half again. Okay, so I have half x square plus y square, and then I differentiate the inner one, so I have 2y, right, and then same thing, how am I doing? So I have y x squared, this is minus half, sorry, so I can also rewrite this term as over here, just that if you really don't know what the hell am I, actually this is wrong, I shouldn't put it minus half, I don't know what the fuck am I doing, yeah, careless mistake. Why am I lagging? I'm just simply erasing. Okay, sweet. Okay, yeah, so minus half, like for example a minus half is actually equals to a 1 over a over half, I mean to the power of half. I think this is the concept. Alright, so to put it over here, I think you know what I'm doing. So I'm just actually proving to you that how I change perhaps this term. I think I just write it in a different color. This term, I just rewrite it in terms of the denominator one. So the minus will become plus at the bottom over here. That's why I have nothing, I have no minus over here, alright? So if you don't know what I mean, then too bad. I've did my best. So yeah, I suggest you just click back to the 1 minute ago and then you just watch. It should be fine. You should understand what I mean. Alright? So now we're gonna differentiate in terms of dx and dt. Maybe I should clear away this thing also. Okay, so what I'm gonna do here is to differentiate dx over in terms of dt, so it's just 2t. So I'm just differentiating this one because 1 is differentiate is equals to 0, alright, which is, yeah, and then y is equals to t minus 1. If I differentiate, I'll have just equals to 1. That's all I have. Okay, so I'll just sub it in. I'll just sub this in, meaning this whole chunk back into this thing, because dz dx is equals to this, dx dt is equals to this, and you know, yeah. So same thing, I'll just sub it in over here. So to make it efficient, hold on. So ta-da! I've just written them. So I'm basically taking this thing, alright, meaning this chunk over here with this and this, I'll just put it over here. So 2tx, 2x times 2t, I put it, and then the denominator is over here. Then you get what I mean. I'm just simply filling in the blanks, that's all. Okay, so this is this one, and this one is this one. If you want to pause the video and you can check it out what am I doing now. Alright, so I'm just simply subbing in what the terms are. Okay, So we are not finished yet because we want to write in terms of find partial z and partial t. So we're gonna write the answer in terms of t, because in terms of time. So what we're gonna do now is to sub in the x's and the y's. So in order to do that, so 2t x is t squared plus 1. So this is simply x, okay, the same thing that I'm doing right now, okay, plus y is t minus 1, so I just put it here, and then I have the same, therefore x squared plus y squared half. Okay, now let's elaborate this dude over here. You can just keep this as an answer. This is just the answer itself, but you want to put nice, then hold on. Actually no leh. I forget that this is in terms of x and y also. So I'm gonna put them out also. Damn. So this will be very, very hairy. But anyway, so x squared plus y squared, so I have t squared plus 1 square plus t minus 1 square I mean half, sorry. Okay, so you can leave this as an answer, alright, because everything is in terms of t's. Alright, if it's you want it to become an answer, then suggestably the best way to present your answer in terms of a neat way is hold on, bam, answer. Alright, so if you want to work it out, the numerator and the denominator, alright, you do it out yourself. I suggest you can do it out yourself because it will help you to practice your ability to prevent any any mistakes, alright, any mistakes that could happen to you. And so this is the first one type of questions that the test may come out. It's a pretty easy and straightforward one. So the next one I'll share with you is another question that deals with some stories telling. So I shall see you there. Bye bye.